Hello everyone, welcome to Coders Camp. So here we are at the third video of our recursion series, where in our first video we saw basics of recursion, how does recursion work and what are the terms used in recursion. And in the second video we have seen one problem, search a 2D matrix that can be solved using recursion technique. So here we are going to solve another problem using recursion technique. So let's get into the problem statement. So today's problem is largest merge of two strings. The input given are two words, word 1 and word 2, and we have to return the lexicographically largest merge you can construct. So we are going to approach this problem recursively in this video. So let's understand this with an example. Here is a given word 1 and word 2. We have to construct our output, that is start getting our word 1, that is C. The letter from word 1 is C and the first letter from the word 2 is B. So which is going to be the highest or lexicographically higher value, which will be C. So first we are adding C and moving our pointer to the next character A. So once now C is added, we removed C. So now it's time to consider A and B. Out of A and B, B is going to be the largest value. So we are adding B and moving our pointer towards C. So now compare C and A. C is going to be our next character because that is higher than A. So moving our next pointer to A. In this case, both A and A are same. So we are adding both A's and then move our pointer towards next value. Here the value at word 1 is going to be B and the character at word 2 is going to be A. B is going to be the higher value, so we are going to add B and move our pointer towards right, and the rest of the words are 4 A's. They are all equal, so we are going to add all A's to the end of the string. So this is going to be the longest or largest merge of two strings according to the lexicographical order. If you are approaching it iteratively, we are going to have two pointers, and every time we check the first character, that is if our word is cab and BCA, we are going to keep our pointers C and B. We check which is higher. If it is higher, add this value and remove it and consider rest of the string and the second string. So once we remove B, then remove that value, consider rest of the string and the first string. So what are we going to do? Every time we take a word, we are converting the rest of the word to a substring and remove the word and iterate it. So let's see how are we going to approach this recursively in our code. So first we are going to compare both the words to find which is the largest. So I'm going to check if word 2 dot compare word 1 is less than 0. That is, we are using the compare method from Java, which compares the first characters of each word and let us know which one will be the largest lexicographically. If it returns -1, which means word 1 is smallest. If it returns some greater value, which means word 2 is smaller. So according to that, we are going to return the value in that. So if our word 1 is the largest, we are going to add the character 1 from the word 1. That is the first character from the word 1. So we are going to put word 1 dot substring zero comma 1. So it is going to take the first character from word 1 and add that to our result. Plus rest of the word we are going to check. That is, if we add character from word 1, then the rest of the word or rest of the characters in word 1 with word 2 is gonna iterate. So we are going to call the same function largest merge with the inputs word 1 dot substring of 1 comma word 2. So what this will do, now we are actually adding the first character from word 1 to the result plus rest of the word 1, that is substring of 1 will break the first character and consider the rest of the characters and pass that as our parameter. and then the word to. If not, if the word to is greater, then we are just going to put the same thing. Instead of word 1, we are going to get the character from word 2. It will add the first character to the result plus word 1 completely and word 2 dot substring dot 1. That is, it took the word 1's first character to a result and then send the rest of the characters as a input. So it iteratively checks every time which is the greater word and add it to the result. So now we found the recurrence relationship here, that is taking the first character whichever is greater and iterating the same function again and again for the rest of the words till the words becomes empty. So here we need to stop the iterations or stop the recursion at some point. For that we need the base condition. So every time we take a word and shortening the words, the length of the words are going to become lesser and lesser. At some point the word's going to become zero. In that case, we have seen if the length becomes zero, then rest of the characters will be combined at the end of the string. So we are going to check if both the words are empty, then we completely iterated both the words. In that case, we are going to check if both the words are empty, then return nothing because we completed the iteration of both the words. If either of the word is empty, that is if word 1 alone is 0, then return rest of the word 2 and attach that to our uh, result. If not, if my word 2 alone is 0, then return the rest of the word 1. Simple. So this is our base condition, that is if both the words become empty, so we have stopped our iteration or completed our iteration of 2 words, so we are returning null. If not, we are returning the rest of the other word. So let's run this. So yes, let's submit. So yes, the solution is accepted. So we have today seen another problem that can be solved recursively. So wait for some more videos on recursion. Thanks for watching. If you like the video, hit like and subscribe.